Let's begin. You're being recorded, so if you want to be on YouTube, you might as well say something really loud right now. All right, Rylan Fred. Okay, here we go. So we're going to create. Remember, yesterday we had this situation. We had this situation where the dolphin dove in here, had a path. Okay, and came back out of the water. Maybe we'll use the other dolphin right now to show how he would jump out of the water. Slow down. So this is how he exits the water. It's yes, he changed. He also doesn't have water with him anymore. He's okay. So we talked about this path right here being a parabola, and it was y equals what? No, what was the? Nobody has it written down. That's fine. Negative x squared. No, sorry. X squared minus 16. And so my question to you was, when did he enter, and when did he exit the water? Remember, this was sea level. You guys all agreed that this was sea level here. So essentially, y represents what? What does y represent here? Sea level, okay, not bad. In general, though, is this sea level right here? Is this sea level? No, but this is all y values. Aren't these all y values here? These are all the y and x values, right? So y represents what, man? Not the axis of symmetry. Y is how high up he is, right? When he's down here, he's negative, right? Wouldn't you say when you're underwater, you're negative? Wouldn't that make sense? And when you're above water, you're positive. So what we want to know is, when is he at 0? So Y represents the height. So what we're trying to do, guys, and this leads to today's topic. We want to know when the parabola is at 0. Does that make sense for everybody? All right, in this here part, we're gonna try to figure out where the parabola hits the x-axis, where the dolphin enters the water and leaves the parabola, or leaves the water. Sorry. So here we go. We found yesterday when we graphed this thing that this was what? What was this point right here? Negative 16, because it is the c value, so this is a negative 16. All right. And what I asked you to do was just sort of guess. Just sort of guess at where these points were. Where did we say these points were? 4 and negative 4. And why did we say the answer was 4 and negative 4? Why? I mean, you can see it sort of, but why algebraically, I guess, is what I'm trying to say. Why algebraically does x equal 4 and negative 4 fit this equation? Yeah, what do you guys think? Good. Okay, so you're saying, look, we can actually solve this thing algebraically, and that is correct. Okay, so what we have is x squared now equals 16, and then to solve this, what do we do on both sides? So those of you who were not here yesterday, this is known as solving by square roots. So x equals plus and minus 4. And so this is what's going on here. Okay? These are how you're going to come up with the answers. This is known as solving quadratics. Why is it a quadratic? Okay, that's fair. It has that x squared. Okay. Solving quadratics by taking square roots. Okay. Rylan, go ahead, buddy. Where did I get the positive and negative from? Well, when you square something, it automatically becomes positive, correct? If it's positive, it would stay positive. If it's negative, it becomes positive, correct? So positive 4 squared would be 16, and that would work. And negative 4 squared is what? 16, so that would work as well. It's already 5 minutes long. 10. Yeah. Jake's question was, before we stop for a second there, Jake's question is, what happens if the leading coefficient, the a value, is not 1? So here's a case where we have 2x squared minus 98 equals 0. So this is still solving. Remember yesterday we talked about solving, meaning find solutions. So obviously, right, this is easy. Find solutions. But what else does it mean? What else is a synonym for solutions? We talked about this yesterday. Roots. That's okay. What else is a synonym? Zeros. Okay, and this is and x-intercepts. And x-intercepts. All of these things are synonyms. And notice, take a look, guys. This is why we call it finding zeros. Look. Because what you do is you set the equation equal to 0. All right? You want to make sure one side is equal to 0. So let me say that again. This is really important to do. Now I set it up, example number 1 on your paper, which is this, is set up like this. But if it's not set up like this, you got to make sure it gets like this. So let's start. So how am I going to solve this? Well, you go back to Algebra 1 and let's hear about some thoughts here. Somebody besides Sid, she's always talking. Somebody besides Laura, she's always talking. Carrie, welcome to class. What do you think? You're going to add 98 to both sides, so let's see that work. And then we've got 2x squared equals 98. And so now we have 98. And now I think you guys know what to do. Jacob, this is the part where you need to pay attention because this is the key to your question here. This is what you do differently because of the you now have to divide by 2. Exactly. You divide by 2 on both sides, and we get a key squared. How do you say squared in Spanish? How do you say to the second? A la segunda? A la segunda? Segundo or segunda? Segundo, da. Or is it just al segundo? Nobody knows. X squared equals 49, and so my final answer is x equals -7 and 7. And so these guys, these would be your solutions, your roots, your zeros, your x-intercepts. Last question, and then we'll talk. Where are these things on a graph? If I were to ask you to graph this, and I'm not, but if I were to ask you to graph just this portion, you guys agree that would be a parabola? Okay. What are these then? These are points. These are the, look on this. Look at right here. This is where it crosses the x-axis. Does that make sense? So these are 2 new points. Like if I asked you for a table, you could tell me, hey, what's one quick point you can always tell me? You guys are really good at telling me, no, 0, 0 is not it. What's the y-intercept here? What's the y-intercept? The y-intercept. -98. So if you were to ask if I asked you to make a table, you'd put 0, -8. What are the x-intercepts? So you put 7, comma what? 0 and comma 0. Right. So this is you've got 3 points. Now do you think you could graph it? I'm not asking you to, but I think you guys are making a connection and that's important. Okay, so we're going to be done with that. Oh no, my computer froze while I'm recording. That's not good. So right now we're going to try another example. This one's really weird. So let's take a look at this. This is a quadratic equation where we want to solve this for x, okay, just like the other ones. We start the same way. I don't want anybody to start any differently, okay? Start this the same way. We're going to, oh, positive 16. Start this the same way. Okay, sorry, so it's positive 16. Everybody got this written down? Oh, it's on your paper. Okay, so positive 16x squared equals -4. We start the same way. How do I start this then? Brady, what's the first step to start this? What did we do before? Let's take a look at what we did before. What was the first thing? Ooh, we added 98. Do I need to add anything to this side? No, you don't. What's the next thing we did then? By? This one we divided by 2. What are we going to divide by over here? So everybody divide by 16 on their paper. Divide by 16, we're going to get x squared. X squared equals what? What is this then? Negative 1/4. Let's use fractions right now because I think it'll be easier for you to take the square root of a fraction. But it doesn't even matter, does it? Yeah, you cannot take the square root of a negative. So you take the square root of both sides. No real solution. No real solution. So Luis said earlier, there are imaginary solutions, but that is an algebra 2 topic. Okay.